Okay, this is for AP Physics. I'm going through the questions that are actually on the AP exam. Some of you guys had some problems with it. Hopefully this will show that the questions were actually not that bad. Maybe the way you're looking at it seems to be more of a chemistry instead of looking through process. First of all, this is question number 1, so if you're following along, you can watch from the slides. You got 2 different balls that are dropped from a height of 10 meters. In the absence of air resistance, which of the following statements are true? As long as they are the correct shape or the same shape, if you have feathers that are in the same shape, they're going to hit the ground at the same time. That is just one of those little things about physics. And again, it's the absence of air resistance, which in a lot of cases, that's going to be how your questions are going to be worded. Absence of air resistance, because you're adding different variables to it. The procedure and the development of a procedure for doing the speed of a runner. Well, first of all, you're going to only have to focus on the ones that are part of the experiment. We have to figure out the speed. How do you figure out the speed? We got a stopwatch. We're also going to have to know distance, which is a meter stick. The only one that is consistent with both is this one here. Again, this one was actually a kind of simple one. You just had to think about process. Let's go ahead and go to number 3. There's number 3. A lot of the things in physics, you're going to look at graphs. You can figure out what the graphs are. You can look at what you're actually trying to find. So if we're looking at the position of a lab cart at various instants, you're going to notice that my units here are going to be this and this. So we're going to have to figure out velocity. So we're going to go velocity equals distance over time, which is now going to be kind of simple. Now when it says 0.5 seconds, I'm just going to focus at my beginning to where I am measuring. So if I do that, my velocity is going to be my change in distance, which is from 10 to 14, which is 4. And then it's going to be my change in time, which is 0.5. That would be 8. So 8 centimeters per second. Again, keep in mind what you're trying to find. This is velocity. It will say velocity. Let's go ahead and go to number 4. Okay, so this is the velocity time graph. Now we're measuring something different. We're not measuring velocity, so I cannot read it that way. We are doing a position one. Basically, we're figuring distance. So what you need to do is kind of look at this as being the difference between speeding up, slowing down, and then my distances are going to start being positive here because I'm moving into a positive direction, and this part's going to be negative because it's below 0. So you can look at this as a regular graph, but you have to interpret too. So what determines the motion here? Well, I'm already in a negative direction. The only thing you have to kind of look at is this one is actually slowing down to 0. If you are at 0 and you're moving from here to here, it has to be slowing down. So the answer would be actually the bottom one. You are slowing down, and this is in a negative direction. If you're above it, it would be like, you know, if I'm looking at number 2, I'm in a positive direction, and I'm slowing down to 0. So that's kind of the way you need to look at this one. Again, it's kind of simple what we're doing on this. So let's go ahead and do another one. So again, I'm at number 5, and as you can kind of notice, questions are pretty simple. Now, this one's a little bit trickier. What you have to kind of think as you're doing this is we look at the positive direction and my acceleration. This is less than 1 meter per second squared. That means I'm actually slowing down. So I am moving in a positive direction, and I am slowing down. I just want to keep up on this. I got to keep track of all the numbers we're using. Now let's go ahead and go on to the next one. Okay, so let's go ahead and erase this. I'm hoping this helps. So you can kind of get a perspective that this actually wasn't that tough of an exam. But again, it's a different way of kind of reading things. It's not like chemistry. Okay, so we have velocity and time. Velocity, time. This is again a displacement. It is not a velocity one per se. So if I'm taking a look at this, I'm just looking at number 1, I am not stopping moving. It is constant. So the object is moving. We are having displacement between these 2 points. The object's initial and final positions are the same. Now that is a possibility, but that's not really the best answer because we know that we move from here to here. The object is speeding up from 34 to 36. 34 to 36. Well, we're slowing down to 0, so we already know that's wrong. Again, I'm going to 0 here. So again, I'm just going through and kind of eliminating choices. This one might be the one you might choose, but it's kind of in a different way you're going to look at it. The average acceleration from 0 seconds to 4 seconds is the same as from 34 to 36. So we're going to look at 0 to 4 seconds. And then we're going to look from 34 to 36 seconds. Now they're talking acceleration, so I can use my velocity, change in velocity over my change in time. That's my acceleration formula. So what I would say about this is if you're looking at parts where it says acceleration, you're going to have to kind of look at it like this. Change in distance over change in time. This is a displacement graph, so I can do the distance. So if I'm going from 0 to 4, it's going to be kind of located here. If I'm going from 34 to 36, it is from here to here. Now I can just go ahead and use my numbers and do an area since I am doing a displacement. So my displacement on this first part going from here to here, well, it's going to be an area. So this is going to be 0 to 4, 0 to 10. I want to make sure that is correct. So we're going to multiply 10 times 4. That's how we figure out displacement, which is 40. Now it's a triangle, so I'm just going to divide it by 2. So it's going to be a displacement of 20. And then I can figure out, let me see on that one. We're doing an acceleration. Apologize. And it's going to be a change in velocity over a change in time. Apologize for that. Just ignore me for right now. Change in velocity is going to be 0 to 10, so it's going to be 10. See how you can get off topic and forget about it. And then my change in time is going to be 4. That's going to be 2.5 meters per second squared on this part here. Now on the acceleration part here, we're going to have a change in velocity which is going to be going in a up direction. So it's going to be well, the change in time is going to be 2. And my change in velocity is going to be 5. 2.5 meters per second squared. So what does that say? Now by a process of elimination I got this one, but we can also prove it with numbers. That will be the first set. Again, I've gone to number 6. My next set will be 7 to 12.